In this video, we're going to take what we've learned about fractions and begin applying them to situations where we see these rational numbers, seeing these fractions in equations. What I would like to stress is that how we go about solving equations is no different with fractions than what we did with whole numbers. It does become a little bit more complicated because of the fractions, but it is the same exact process. So let's take some examples. If I have x plus 3/4 is equal to negative 1/6, I'm going to do the same thing I did before of splitting this up, okay, to two sides. I need to subtract the 3/4 to get the x by itself, which means I also need to subtract 3/4 on this side. The difficulty becomes that I cannot just do negative 1/6 minus 3/4. I'm going to need to change this to a common denominator of 12. So it's going to be negative 2/12. This is going to be negative 9/12. And if I add those together, I get negative 11/12. Okay, and that's going to be my solution. So what I did before with equations is going to be the same. There's one situation I would like to address in a special way today. Just keeping in mind the steps are all the same. There is a way that we can use something called a multiplicative inverse to solve particular equations. So the example will come when I have something like 2/3 x is equal to 9/10. Okay. One way about solving this is saying, okay, if I have 2/3 times x, I can undo that by dividing by 2/3. So the 2/3 will cancel out. I'm going to need to do keep, change, flip. So I keep the 9/10, I change the division to multiplication, and I flip the second fraction. In this case, x will equal 27/20, or 1 7/20. Okay. Now, instead of using this whole idea of dividing the fractions and then having to go through the keep, change, flip, a lot of steps. One way about handling this is with the same problem, 2/3 x is equal to 9/10, is to multiply by what's called the multiplicative inverse. So the inverse of 2/3 is going to be 3/2. It's the reciprocal. So I'm going to do the same thing over here. The 3's cancel, the 2's cancel, or simplify, leaving me with just x by itself. I can multiply. 9 times 3 is 27, 10 times 2 is 20. So I get the same answer as I did over here. And actually, if you will notice, what I have up here is exactly what I have here. So it's basically like, instead of setting it up as a division problem, right from the forefront here, I'm going to do that keep, change, flip. Okay, here, keep this, change the division that I would have had to multiplication, and then flip what I would have been dividing by. So it's just a way of trying to make life a little bit easier when I'm broaching sort of this work with equations. Okay, so this is, in particular in this section, anytime you have something being multiplied by x, a fraction being multiplied by x, encourage you to use this multiplicative inverse.